Hello everyone. Our previous lesson was on direct variation. So what do you think partial variation is? Partial variation is a relationship between two variables, so x and y, in which the dependent variable, that's y, is the sum of a constant number and a constant multiple of, well, that's getting crazy, right? That definition is really getting a little tedious, so let's try to make sense of that. So for direct variation, this is our last lesson, the equations look like this. For example, if you were getting paid $20 an hour, your earnings would be 20 times however many hours you worked. But in partial variation, the equation would look like this. So there'd be some number, a constant number added on, or subtracted. So you might be getting $20 an hour plus $7, maybe a bonus or something. So there's this little extra piece here. So that's partial variation. That's how we identify it by looking at the equation. Direct variation doesn't have that extra constant added on. So direct variation doesn't have a constant added on, a fixed number. That's how we tell by looking at the equation. When we're looking at the graph, when we graphed anything with direct variation in our last lesson, it was a straight line which passed through the origin. That's really important, is that it passed through the origin. So right here, this one on the left, it's going right through the origin. But for partial variation, it does not. So here's my origin. I'm highlighting the origin on the graph on the right here. And the graphed line, the purple line, is not passing through the origin there. So for partial variation, that's the purple word here. It does not pass through the origin. So looking at a graph, you can tell direct has no extra number on, a fixed number, and direct on a graph passes through the origin. So that's how you can tell by the difference between the two. So partial variation, that's the only difference. It just doesn't pass through the origin. So here's our one example for today. It's a big one. A school is planning an awards banquet. Whenever we have a word problem, we want to do one sentence at a time. So here's a little picture so you can get an idea of what an awards banquet might look like. The cost of renting the banquet facility and hiring the staff is $675. So the building itself and the people to work there the night that you're having the banquet is $675. That's a flat rate, okay, $675. But there's an additional cost of the food, $12 per person for the meal. So you're not just paying $675, you're now also paying for the food on top of that. So this number is changing based on how many people are coming. The first part says identify the fixed cost and the variable cost. So these are important pieces of terminology. Fixed cost means the cost that won't change, and that's your $675. It's going to be $675 if you have 100 people come to your banquet or if you have one person come to your banquet. This number right here is to pay for the facility and hiring the staff. So that number is fixed. That's $675. Now the variable cost is the one that you're not sure of. You're not sure how much this part's going to cost you, and that's the food, because we don't know how many people are coming for sure. So we know it's $12 per person, but we don't have a final number on the food. So that's a variable cost. Anytime you see the word per or a slash meaning per, that's your changing number. That's the number you're not sure of. The next part says write an equation to represent this relationship. Okay, equation. Well, we don't have any letters or anything here. There's no x's or y's or e's or t's or anything. So we need to identify some variables. We're going to have P represent the number of people. Again, anytime you see a slash with person or like this needs a variable. So this is going to be number of people for this one. And then the other part of the question is the total cost. Your 675 plus all of this, that's your total cost. So those are the two variables that we're going to use. Now to come up with an equation, if you remember from direct variation. So direct variation questions look like this. We had like a y equals, and we had some number times the x value. So for the question where you were working, you maybe had your earnings is equal to, and the previous slide had $20 an hour, and then your H is how many hours. So you work 2 hours, you put a 2 there. You work 15 hours, you put a 15 there. So direct variation looks like that. What we're doing now is partial variation, which is also sometimes called indirect variation. Partial variation, its equations look like this. Y equals, so we still have this part here, but then we have something added on, just a constant, just a number. So it's always going to look like this. Our equations will always look like that in partial variation. So the part that gets this piece here, that's wherever your per is. That's going to go there. This is your fixed number here. So that's just a single number, the number that doesn't change. That will be your $675. So there's our equation. We've got our fixed numbers here, 675. So you're paying $675 plus $12 per person. That's what that equation is saying. You don't have to write it that way. You could rearrange the two pieces there if you wanted. I'll just show you. You could have it like that as well. It's the same numbers, it's just in a different order because we do see it in that second order a lot. So that is how we create an equation. So I'm going to erase the stuff I wrote here in the middle in purple because I need that space on the slide for something else. So press pause if you need to and copy that down. I'll erase it. All right, so we've got an equation, and that's extremely helpful for our next part, which is graph the relationship. Do you need all 4 quadrants? So here's a grid. Do you need all 4 quadrants? Remember what that means. If I drew a line straight down the middle here, and this way, I would have 4 quadrants. 1, 2, capital Roman numerals, 4. Do we need, so I don't know yet how to set this up because I have no idea. I have as an equation. I have no idea what kind of numbers. Am I going to go like 1, 2, 3? I don't know. So I need some more information before I can graph it. So the next thing, the way I'm going to get that is with a table of values. So I'm going to set up a table of values like this. What's going to go here and what's going to go here? So always in the first box is your independent. Independent goes there, that's your X. And in this case, that's, remember, it's the one that has the per person. So that's our P is going to go here. The P is going to go there. And then obviously on the other side, we've got our C left here. So that's how we always set up the table of values, independent first and then dependent. So I'm going to erase this again too. So press pause if you want to copy it down. Let's get rid of all that because I already have kind of pre-typed in a chart here. So there's our chart already set up. Now what am I going to put in there? For people, I need something to put underneath the column for number of people. How many people? Well, I don't know. What's a reasonable number of people to have at a banquet? Well, first of all, I can have 0 people. I know that. But what's a maximum? So here it gets a little bit subjective where you kind of think of a good number. For a banquet, I would say 200 is a good maximum. You certainly can have more than that, but we'll just go with 200. You certainly don't want to go with 1, 2, 3, and 4. That would not be a good table of values. So I'm going to just fill in these spaces with a few more numbers. So now I'm going to substitute these values for P into this P here to come up with a cost. So if 0 people come to my banquet, is the cost equal to 0? If so, it's direct variation. If 0 people come and it's 0 cost, then I have direct variation. But that's not the case. I have to pay $675. That's a fixed cost. So even if 0 people come, I sub in a 0 here, I still get 12 times 0 is 0 plus 675. I still have to pay $675. What if 50 people come? So here we're going to get out our calculator, and we're actually going, you're going to press pause and you're going to go ahead and finish this chart here. Try to do it on your own. Don't just keep playing the video. I want you to practice with this table of values. fill in the whole chart all the way down and get all the answers here. And when you come back, I will have it all done for you, but you need to press pause and do it yourself, please. All right, there we have all our table filled in. So we're still on part C, graph this relationship. Do you need all 4 quadrants? All these numbers are positive because it's number of people. How could it be negative? And our cost is all positive. So I only need quadrant 1 when everything is positive. So I'm going to erase all these green lines here, and I'm going to just use the first quadrant. So that's good. I can use this whole piece of grid paper here just for the first quadrant. So now I need to label. This is my x-axis. Okay. But for this word problem, it's not x, it's p. So I'm going to put a p over here. And p is for the number of people. So I'm just going to label that at the bottom. Okay, there's my p-axis. What scale am I going to use here? So I've got 0 to 200. So a kind of a quick way to figure out how many, what to count by, what intervals to count by. I don't want to like count by 100s, right? If this was 100, 200, that's ridiculous to squeeze my whole graph into that small space. My maximum number is at 200. So I counted all these grid lines, 1, 2, 3, 4, 5. I counted them all, and there's 16 of them. So if I take 200 and I divide it by 16, I get a bit of a weird number. I get 12.5. Now I'm not going to count by 12.5, so that's not going to be, I'm not going to call my first mark here 12.5. And my next one is going to be 25, right? I'm not going to count like that. So I'm going to round, I'm going to move it up. So I'm not going to count by 12.5s. I want to go a little higher than that. I can go to 15 if I'm comfortable counting with 15s, and I am, but maybe you're not. So maybe you want to go up higher than that. So if you don't want to do 15, maybe 20. Count by 20. So the higher number you pick, the more you're going to crowd in your space. So just try to keep it reasonable. But 20 is good. So let's count by 20s here. I'm not going to label every one. I'm going to skip one. So I'm counting by 20. So we've got 20, and then this one here is 40, 60, 80. I'm counting by 20s, but I'm labeling every second one. So 80. Then we have 100, and then we have 120. So I'm just going to press pause and fill this in, and you guys do the same. So I certainly got all my numbers in there, no problem. I got up to 200. I got beyond that. Next, let's look at our y-axis, or our independent. There we go. And my largest y value down here is 3075. So there's one thing I could do here. I could condense the graph. What that means is if I put a little zigzag at the bottom here, I'm kind of compressing the graph. Whoops, that's not a very good one. What you're doing is imagine kind of my hand at the top here, and I'm pushing down on this. I'm pushing down, and so I'm kind of squeezing a bunch of values, crowding them in down here. So I might be crowding in all the numbers from 0 to 600 here, and then I could start with my first grid line as being 600, and then I could count by 100s from there. I could go 700, 800. So this first piece that I condensed here is not counting by 100s like the rest of it is. It doesn't count, right? We don't have to worry about it matching the rest of it. I'm not going to do that here. I don't really need to, and I just want to practice the little technique I showed you earlier. So let me erase all this. I'm not going to compress the graph. What I am going to do is count again how many grid lines I have from the bottom to the top, and I have 16. So I take my big number there, 3075. I divide it by 16, and then I take a look at the number I have, and it's kind of a weird number, but I'm going to round it up. So I've got about 192. I'm not going to count by 192. Nobody counts by that number. So I'm going to round it up to a nice even 200. So I'm going to count by 200s on my C-axis. I will label every second one again. So although I'm counting by 200s, this first one that I'm showing is going to be 400, and then 600, and then 800, and so on. And I'm going to press pause and fill the rest of this in. Be sure to let me know. Sometimes I make mistakes because I'm counting and I'm writing and I'm talking all at the same time, and so sometimes I miss an interval or something like that. If I do, let me know, and then I will come back and correct the video. Okay, I've got all my scale on, which is as much work in the question as anything else. Coming up with these numbers I found was easier than trying to figure out my scale and then writing it all down, right? This was more effort. But once it's done, it makes it really easy to plot these points. So that's my next step, is to plot the points. My first coordinate is 0, 675. So I'm going 0 on my p-axis, which means I'm staying here, and I'm going up 675 units, so I'm just going to put a dot right about there. And this point is really important. It's important to note that we're not passing through 0, 0. That would be direct variation, but we're up here. That's what makes it partial variation, because 0 people did not mean 0 cost. So 0, 0 is not on here. So let me put my first dot on there, maybe right around here, I guess, somewhere. Okay, so we're going to keep putting all of our points on, and they should form a nice straight line. So I'm going to press pause while I do that. So there's my plotted points, my ordered pairs, and they look pretty linear, which is good, because some of these points, you know, I had to kind of estimate where they should go in terms of the grid lines. So I'm going to get my ruler, which is always very painful for me to do with this tablet, and I'm going to try and draw a nice straight line through these points, and yours should be absolutely hitting all of those black points, and no arrow on this side because the graph doesn't continue in this direction, because we can't have less than 0 people. But it's possible we had more than 200 people for sure, so we're going to put an arrow up here to show that this data would continue on in that direction. Okay, so let's just pretend that that lined up there, but it didn't, but yours should have. So showing partial variation because we didn't go through the origin. Nice straight line and an arrow on the end in this direction because the data does continue on. So there's our graph. Okay, so that's probably the hardest part of the question done, coming up with a graph, just given a few sentences here. We just had a few sentences, and from all that we came up with a beautiful linear relation. The next question says, use your equation to determine the total cost if 500 people attend your banquet. So here's a new number. Where's the number going to go? Here's our equation, either of these. Where's it going to go? Is the 500 a C value or is it a P value? Well, it says right after the 500, it says people. So it's got to go in for P. It's a P value. There's our equation. We put 500 in for P. The only way you'd put it in for C would be if the question said you have $500 to spend. You know, your total cost is 500. How many people can you have? Then you would put the 500 there, but you would be out of luck because you need 675 just to pay for the building. So that goes there. We multiply and add it up, and we get 6,675. And anytime you have a word problem, which this one certainly is, we need a sentence at the end. Therefore, if 500 people attend the banquet, the cost will be $6,675. So that's your one big example, and it's a good summary of all kinds of stuff, creating your own table of values, how to get your scale on your X and Y, your Y axis, how to come up with an equation from nothing. How do you take all this and turn it into an equation? Which one's independent, which one's dependent, fixed costs. There's a lot of good information in there. So the lesson wasn't very long, but it was packed with good information. So make sure to practice this, try your questions, and let me know if you need help.